Welcome to my channel. Today, we are going to explore the fascinating world of computer cooling systems. If you have ever wondered how computers manage to perform heavy tasks without overheating, then this video is exactly what you need. A computer cooling system is one of the most essential components in modern PCs, laptops, and even gaming consoles. It helps maintain optimal temperatures, ensures long-lasting hardware performance, and prevents damage that could occur when internal components generate excess heat. Before diving deep, let us first understand why cooling is so important. Every computer is built with a central processing unit, known as the CPU, and often a graphics processing unit, or GPU. These components handle millions of calculations per second. During intense operations, such as gaming, video rendering, or scientific simulations, they produce a lot of heat. Without an effective cooling system, the hardware could throttle, slow down, or even fail permanently. That is why cooling solutions like fans, heat sinks, and liquid systems play such a critical role in computing technology. Computer cooling systems come into major types: air cooling and liquid cooling. Air cooling relies on fans and heat sinks to disperse heat into the surrounding environment. This method is widely used because it is cost-effective, reliable, and easy to install. On the other hand, liquid cooling uses a closed-loop or custom water cooling setup. Liquid systems are more efficient at moving heat away from powerful components, making them popular among gamers and professionals who require maximum performance. Each method has advantages and disadvantages, and choosing the right one depends on your computer needs, budget, and long-term goals. Before we continue further, I would like to take a quick moment to speak with you directly. Please subscribe to my channel so that you never miss out on new educational and tech-related videos. If you are finding value in this video, make sure to like, share, and leave a comment below. Also, do not forget to turn on notifications so that you will always be updated whenever I upload a new video. Now, let us move deeper into the mechanics of how a cooling system actually works. At the heart of cooling lies the principle of thermal transfer. Heat generated by the CPU or GPU is absorbed by a conductive material, often a copper or aluminum base plate. From there, the heat travels into fins or a heat exchanger where airflow or liquid movement carries it away. In air cooling, this is where fans push or pull air to dissipate the heat. In liquid cooling, the liquid carries the heat to a radiator where it is expelled through airflow. Both systems use the natural physics of conduction, convection, and in some cases radiation to maintain stable temperatures. Another key element of cooling systems is thermal paste. This substance, though often overlooked, plays a vital role in filling microscopic gaps between the CPU and the cooler. Without thermal paste, air bubbles could form, which would drastically reduce heat transfer efficiency. Reapplying thermal paste every few years is often recommended, especially for people who want to keep their systems running at peak performance. Some advanced computer users opt for custom liquid cooling loops. These involve reservoirs, pumps, tubing, and radiators. While more expensive and complicated to install, custom liquid cooling offers superior thermal management and often allows for aesthetic customization with colored coolants and RGB lighting. Enthusiasts and overclockers use these setups to push their hardware to its limits without the risk of overheating. When discussing cooling, we must also touch on airflow management within the computer case. Good airflow design ensures that cool air enters and hot air exits the system efficiently. This means arranging fans in a push-pull configuration, using dust filters, and regularly cleaning components to avoid dust buildup. Poor airflow can trap heat inside, even with strong cooling hardware, leading to suboptimal performance. Noise is another consideration when choosing a cooling system. Air cooling tends to be louder since multiple fans may spin at high speeds. Liquid cooling systems, although quieter in many cases, can still produce pump noise. Balancing cooling efficiency with acoustics is an important factor for users who want a silent working or gaming environment. In the modern computing world, companies are also experimenting with advanced cooling technologies such as phase change cooling, thermoelectric coolers, and even immersion cooling where entire systems are submerged in special non-conductive fluids. While these methods are not yet common in consumer PCs, they represent the future of high-performance thermal management. So, whether you are building a budget desktop or a high-end gaming rig, understanding computer cooling systems is essential. It not only extends the lifespan of your hardware, but also improves efficiency, reduces crashes, and enhances the overall computing experience. Choosing the right system for your needs can make a huge difference in performance and reliability. As we come to the end of this video, I want to remind you once again to subscribe to my channel so that you can continue learning more about technology and computers. Please like this video if you found it helpful and share it with your friends or anyone interested in computer hardware. Do not forget to comment below and turn on notifications so that you never miss any of my future uploads. Finally, thank you very much for watching this video and supporting my channel.